Hello, how's everybody doing today? Today we're going to talk about inverse relations and functions, okay? Be able to find the inverse of a relation or a function. You'll be able to do that uh, in an equation and in a graph. So by the end of the day, that's what you'll be able to do. So we need to define some of these terms to get started, okay? A relation is just a set of ordered pairs, x, y. Inverse, what we're going to do is we're going to take the y's, or take the x's, make them y's, take the y's and make them x's. We're just going to put them in opposite spots, okay? That's all we're doing, all we're using to define inverse, okay? To determine whether a relation or an inverse is a function, it's back to our same question we've talked about all this year. Does each element of the domain have exactly one element in the range? Does it pass the vertical line test? And our other sentence is, for every x, there's one and only one y. Okay, so now in a graphical sense, if I want to find, if this is relation M, just I don't know whether it's a function or not, just a relation, if I want to find the inverse, pretty simple. All I do is say, well, this is now a y, and this is now the x's. Okay, that's all you're doing. You're taking the x's, making them y's, y's making them x's. So what we have down at the bottom is the graph of m, okay, the original, uh, the ordered pairs, 0, -1, so forth and so on. Now we're just going to graph the inverse, okay? So first ordered pair is -1, -2, so those are going to be reversed. So my x is -2, so left 2, and down 1, that red dot there is your first one. Okay? X is now -1, y is 0, plot the point. X is -1, y is 1, plot the point. X is -2, y is 2, plot the point. And what you'll notice here is, and what you'll notice about all inverses is basically they're just, in a graphical sense, it's going to be a reflection over the line right here. Okay, what's the equation of that line? At this point, we should know, well, intercept is at 0, 0, slope is up 1 over 1. That is y equals x. That's the line y equals x. So all of our graphs get flipped over that line. So we'll see, if you look at this now, on the vertical line test, the original, which are the black dots, that definitely passes the vertical line test. So the original relation was a function. Okay. But when I switch the x's and y's, I get my red dots. And you'll see right here, I get a breakdown here for x of -1. I get two y values. I get a y value at 0, and I get a y value at 1. So this does not pass the vertical line test. So the red, the inverse, is not a function. Okay. So we learned that, just because we have a function originally, when we make its inverse, it isn't necessarily a function. Okay, and we can run that out, the relationship the opposite way, which you'll see here in a little bit. All right, so let's go ahead and move into an equation here. Find the inverse of this. So now we don't have a graph or anything. All we're going to do is, very simply, we're going to rewrite the first line. We're going to call this x now, and we're going to call this y squared minus 2. And then, so step 1 is switch x, y. Okay. And step 2, well, what do we always do when we want to get y by itself? So let's just say solve for y. Okay. Pretty straightforward. Okay. So let's go ahead and do that. And in this case, we get x plus 2 equals y squared. And we get, let's see, take the square root of both sides. And we get y equals plus or minus the square root of x plus 2. Okay. And that, hopefully, from our lesson today, we now you can graph that thing there, and you know what that looks like. All right. But basically, so I'm going to get two half parabolas basically, and that is going to be that. That's your inverse. You're also going to see this noted this way, the notation. You'll call this the inverse. Okay. F inverse x, so write it like that. This is the exact same thing. It's just a notation. Okay? Now you can find an inverse. You found an inverse algebraically and in a graphical setting. Okay? So let's move on. Let's work a couple more of these. So let's there's a pretty version of that. There's that guy. So you can look at that. Now let's go to example 3. All right, let's graph. First of all, let's graph minus x squared minus 2. Okay, so let's go and we go down 2, right? If x is 0, y is negative 2, making it basically a little t-chart here. X, y. If x is 0, y is negative 2 in this guy right here. Okay, and then, well, I've got a frown. Okay, and x squared, we know how x squared behaves. It goes like this. Okay, and if I extended this here, it would be basically uh, 2, 4, so down 1, and 2, 3, and like this. Okay, this is a little bit of overkill, but we can plot those points. Again, you could use a t-chart, but hopefully at this point in the year, you know how the graph of y equals x squared works, and all we're doing is taking that picture and flipping it uh, in the x-axis, okay? And we're moving it down to because of this right here, okay? Now, let's make a red picture here, and let's go ahead and just make a t-chart, okay? So y equals. So let's plug in. The first thing I need to do here is I need to say, well, where does this thing start? Well, I got to talk about algebraically minus x minus 2 has got to be greater than or equal to 0, right? Because I can't have stuff under the square root less than 0. That's an important concept. So minus x is greater than or equal to 2. X is less than or equal to negative 2. Okay, so negative 2 is the first one I'm going to plug in there. If x is negative 2, basically y is 0. We plot that point. And what's going to happen here is I've got two graphs here. If x is negative 3, then that becomes 3 minus 2, so I get 1 there, and I get a point here. And if x is, uh, and I get a plus minus there, so I get that as well. So basically, I get this picture going sideways. So now, again, I can kind of follow the pattern here. I shouldn't have to do anything else mathematically in my table. And 1, 2, 3, there, and there. And now I've got this red parabola going sideways. So two square root functions, plus minus, basically make a parabola, okay? And in this case, it goes sideways. And again, we can see that the red parabola does not pass the vertical line test, so he is not a function, where the blue guy is a function. Okay, definitely passes the vertical line test. All right. Okay. Let's go ahead and take a look at one more of these. Let's go ahead and actually get two examples here. See if we can get to these. There's the pretty version of that. Okay. All right. So let's graph this guy right here. This is basically a line, and again, we're still harking back to this idea of, and hopefully you can see it here. Here's the line y equals x. Here I'm putting it in green. Okay. And you'll see that the red graph is a reflection in that green line over the blue graph. Okay, those are a match there. Okay. So let's go ahead and if I want to graph y equals 3x minus 10 in its inverse, let's go ahead and graph y equals 3x minus 10. I'm going to do that in blue. Okay, so minus 10 is my intercept, and up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. Okay, we just draw right through there. Okay, all right, so now its inverse, well, I got to find its inverse, right? So let's go ahead and do that. So let's go ahead and switch the x and the y and get y by itself. Okay, so divide by 3. Call that just x over 3 plus 10 over 3, which is 3 and a third. This is y inverse. And again, you could also see it written this way. But the nice thing about this one, I'll go ahead and graph him in black here, is so up 10 thirds. And then, again, I'm estimating there. And then my slope is 1/3, so I'm up 1 over 3. It gets me this point right here. And I'm up 1 again and over 3 here. And you can see this crisscrosses right here. And hopefully you can see, and you can always check these in your graphing calculator if you wanted to. What you would do is see, oh, do these two lines, since they're both linear, that's nice, do they cross on the line y equals x? And even with my limited artistic ability, you can see that all three, and you should get this every time for linear functions, uh, they all three point across at one point. All three lines, the y equals x, which is in red, okay, the original equation, which is in blue, and the inverse, which is in black. They all cross at one point. Okay, they all cross at one point. Okay, we'll go ahead and make that part one, and I have a couple quick examples here to put in for part two, but we'll go ahead and make this just day one right here. All right?